Hello everyone, welcome to today's webinar. My name is Kapil and I am the marketing manager here at EDB. I will be your host today for this webinar on DRITA and Pgbench for PostgreSQL DBAs. I am joined by Mansur Shaikh, Senior Sales Engineer at EDB. Now, briefly before I turn it over, I just want to go through a few housekeeping items. This presentation is being recorded. We will be sharing the slides along with the recording after the session. The lines are currently muted. If you have a question, please feel free to submit it in the Q&A panel. Our speaker will address the questions towards the end of the session. Since all of us are currently working from home, there's a possibility that we face some connectivity issues, especially because today's webinar will be demo-based. We request your patience in any such circumstances. And now I will hand it over to Mansur.
Thank you, Kapil. Hey, hi, folks. Good morning, good afternoon. Let me discuss the agenda. Today, we'll discuss database benchmarking tools, Pgbench test, default script that will be used for benchmarking, DRITA snapshot, DRITA functions are there, and how we can simulate DRITA with the Statspack, then DRITA reporting functions. Generally, what happens that when we work as a PostgreSQL database administration, we feel that there should be some tool similar to AWR Statspack. And I have to calculate, I have to do some benchmarking on my database, whether my database is that much capable to perform that load. So in that sense, you can do the database benchmarking on your PostgreSQL database. Apart from that, how DRITA will help you to find out the wait events, session events that we will be discussing in today's webinar. Database benchmarking can be defined as a process to measure the performance of a database. It helps the administrator to prepare the system for their application needs. As a DBA, I am more concerned about whether my database is that much capable to handle the load or not. And to figure it out, I can use benchmarking and I can do a stress test. I can load the data into my database and I can find out that whether my database is capable enough to handle that load. It also helps to detecting any shortfalls or any problematic area like unoptimized parameters, memories, or any disk issues. So database benchmarking helps for measuring performance, find out how much load a server can take. Another thing that you might want to do is to compute advanced server with other databases. That's where benchmarking can help. Sometimes you used to compare different databases. Yes, I want to compare my Postgres advanced server or my PostgreSQL database with other databases. That time I can do benchmarking. I can find out the total TPS, total latency, and based on that, I can select the data for handling the load. Benchmarking tools. We will be covering Pgbench tool for today's webinar, but there are various open source database performance benchmarking tool to benchmark the advanced server or other databases. When you will do the benchmarking with the Pgbench, you need not to install Pgbench separately. That can be installed automatically when you install Enterprise DB Postgres Advanced Server. That is ADB's advanced server, which works on top of PostgreSQL. The same engine it has, but some added functionality similar to PostgreSQL, but it has some added functionalities are there. Now, before that, there is another tool that is a Benchmark SQL and Hammer DB. They are also used to do some benchmarking for other proprietary databases like Oracle SQL Server as well as a PostgreSQL. Let's have what is a Pgbench. Pgbench is one of the simplest program available to run benchmark test on the PostgreSQL database. As I said, when you install Enterprise DB Postgres Advanced Server, there is no need to separate install Pgbench. That can be automatically installed once you install Enterprise Postgres Advanced Server. Pgbench is executed by a default location, that is the Pgbench executables. The binaries are located in default location, that is user/edb/as12/bin. It's a simple uh, TPCB application, that is transaction per second benchmarking application, and works on transaction based application. We can do the Pgbench. There is a simple script is there that I'll be showing. In that script, there are some transactions are there, and that simulate a simple banking application where we have banks, where we have accounts and the tailors, and we will perform some transaction on the banks. Let's say that I have a bank, one bank, multiple branches are there, might be one branch is there, multiple accounts are there, and the tailor machine are there. So here I'm using one of the script which is showing the banking application which has accounts, tailors, and we'll be performing some transaction on a bank where we will run Pgbench test. Pgbench working, that when you will run Pgbench, if you want to get more information about, as I said, TPCB, then just go on a tpcb.org. You will get more information about what is a TPCB like of test is there. When you run Pgbench, you can run multiple session. You can connect to multiple databases. So let's say that when I will run a Pgbench, I can simulate like that. I have multiple connections are there. I have multiple transactions are there. I have multiple SQL statements are there. Even you can decide the scale factors when you will run Pgbench. So Pgbench is a tool. I am taking one of the script. As I said, the banking application is there. And in banking applications, there are multiple statements are there, multiple DML statements are there, DDL statement is there. So like that, for banking script, which I am going to use, in that it is a default workload involves 5 select, update, and insert commands are there. When these transactions are running on the database, should have some specific tables, and on that particular tables, I am doing some transactions. So specific number of tables that are required, that needs to be loaded first. So when you will uh, plan to work with the Pgbench tool, so before that, what you have to do, you have to load some tables, you have to create some tables, you have to do some transaction, and once you do the transaction, you can connect multiple sessions, you can do multiple transactions on that. So for that, what I will do, I will prepare a database for Pgbench. As I said that you have to prepare your database for Pgbench. While preparing the database for Pgbench, I can use -i options. So that will initialize or it will create the populate required tables are there. So by using Pgbench utility, generally it creates 4 tables, that is a Pgbench history, Pgbench tailor, Pgbench accounts, and Pgbench branches are there. So on a snapshot, you will see that I have created a table that is a create DB test DB. So I have created one database, that is test DB. Once you create the test DB database, just you have to run a Pgbench tool or a Pgbench command. So as I said, Pgbench is automatically installed and it is available in the bin directory. Just Pgbench -i option to initialize it and just give the database name, that is testdb. You can also specify scale factor while running a Pgbench, can also run on a custom database. So either you can define the scale factor as well. So let me show you. So preparing database for Pgbench, how I can verify. So Pgbench -i creates 4 tables: Pgbench accounts, Pgbench branches, Pgbench history, and Pgbench tailor. So here you will see that there is a scale factor, that is a 1. So Pgbench accounts, there are 100,000 accounts are there in one branch, and 10 tailor machines are there. You can increase the number of rows, as I said, by using the scale factor. Let's say that I want to increase 200,000 accounts I want to do for 2 branches. In that case, I can use -s scale factor. So in this way, whenever you want to do some Pgbench test on a particular tables, so you want that much load on particular table, so just increase the scale factor option, so it will increase the load on particular table. Even while doing Pgbench test on particular tables, you can do unlock the tables. That means you don't want the wall files for particular tables. So I can unlock it. Can be used to create all table as unlocked. And even the test which you are performing on a particular database, the particular tables, you want that should be on a separate table space that I can do. I can keep these tables on a separate table spaces. As I said, if you want more data, you can increase the number of branches that will add more accounts and tailors into your database. Bigger the scale factor, more the data inside your database. You can increase scale factor using -s option. You can also specify -f to fill factor. By default, there is 100. You can specify 80% and rest of space can be used for future use, as I said about unlocked table spaces. So before that, just what we will do, we will populate the table, we will create the database. So what here I have installed Enterprise Postgres Advanced Server on my Linux machine. So I will log in with my Enterprise DB. So I have logged with my Enterprise DB user. I'll create one database. For creating database, I will connect to my database. I have connected to EDB database. I'll create one database, create database. So I can see that test DB, this database I have created here. After that, what I will do, that I will run pgbench command and I will initialize the database. So I'm initializing the table on my database test DB. For that, as I said, -i option that can be used. So pgbench is available. This program or the command is available in the bin directory. So I can simply run from here pgbench. I am giving the scale factor to -s2 or initializing the tables. It will populate the tables in my database, that is a test DB. This will initialize the database. Now the table contains around 200,000 rows. Why earlier it was showing in 1,000 rows, but now I have given the scale factor, that is 2, initializing these tables into my test DB. So before that, pgbench. Just run it. So just pg. Just specify the properly, that is pgbench -s 2-i test DB. And it has, see here, that pgbench accounts, pgbench branches, pgbench history and tailors tables are created. 100,000 of 200 tuples are there. And I will connect to my PSQL, that is the database, that is a test DB. And I can see that the tables are populated. 4 tables are populated here. So in this way, I have created one database, that is a test DB. I ran pgbench program on test DB, and I have given the scale factor, that is 2. -i option, it will populate the tables and it will add the rows into multiple tables, which is showing on the slide. So that's way, in this way, I have initialized database for pgbench test. Now, running a pgbench test. Once your database is initialized for benchmarking, you can now run a pgbench test using pgbench command. But while running a pgbench test, while doing a pgbench test on your database, so -i option now you need not to use, because already we have I option is for initializing the tables on your database by using pgbench utility. This database must have tables when you run pgbench test on particular database, or whenever doing any transaction, you should have some tables in that. So now I have 4 tables in my database, that is a test DB. When you run your benchmarking with pgbench command, there are different options are there, which you can see on a slide. So -c, that is a client, number of concurrent database sessions. So if I say -c, if I'll provide 2, say there are number of concurrent database sessions will be 2, and the default is 1. -c, it establishes a new connection for each transaction. That is in capital C. So if I provide -c 10, so it establishes 10 new connection for each transaction. -f file name, you can give the script file name, you can customize the script, and you can use even the default script which we have. While using the default script, you need not to provide the script name, but if you are giving any another script where it contains number of insert updates or any transaction related script is there, you can provide -f. Then -j, number of worker threads within the PGBench. -S perform select only transaction instead of TPCB like test. You don't want to do some DML transaction, you just only want to do select transactions. That time you have to provide -s. -t, it is a number of transaction each client runs. So for example, you want 100 transactions by 10 clients. That way you can simulate. -t, that particular transaction for how much time, that is a -t second, and that will be provided. And the log prefix, log the test result in your log files. So this is the default script. So this, when you will do some transaction, this default script will work. That is executed by Pgbench test. This works as one transaction consists of 5 statements: update, update. There is a select as well, and update, insert. So first update, then select, then update, then insert. This particular script is run again and again through multiple sessions when you are performing benchmarking test. So Pgbench, see, this is the program on a slide. What I did, that is a Pgbench utility for 10 clients for 60 seconds. So what I'm doing here is a snapshot, which I have ran a Pgbench test on a test DB, Pgbench -c 10 hyphen capital T 60 and test DB. That is 60 is a 60 second. At the end, you can see that there is a number of transactions per second, including connection establishing and the TPS 886. So for that, you see here the scale factor is 1. That is nothing but for one branch. Number of clients are 10. I have given the number of clients are 10, and the duration 60 seconds. So number of clients for duration 60 seconds, 10 clients are doing a transaction on particular database, that is a TSDB, and what are the transaction, which transactions are there. So this is the script they are doing the transaction, and how many rows, that which we have already seen that there are 10,000, 100,000 rows are there for one branch. The 100,000 rows, that is nothing but 100,000 accounts are there for one branch. We are doing this transaction. And when we do this transaction, I got TPS around 885. So Pgbench test with 10 different sessions for 60 seconds on testDB database. At the end of the test, it will display TPS count, including the connection established and excluding the connection established. So for that, what I will do, that I will just go for, and now I will run Pgbench utility. Let's say that how we can do the transaction and how it will help you to find out what is the TPS when I will do the load on my particular database. So let's say just I'll connect to my enterprise DB user. So here is an enterprise DB user which I have created while installing ADB Postgres Advanced Server. Now I want to run the test on my previously initialized database named testDB. I'm going to benchmark my testDB database, and I'll get TPS count or transaction per second count on my database. So for that, what I will do, Pgbench -c, that is number of connections, then 20 connection I am putting here for time 60 seconds. And what is my database? TestDB. So it will wait for 60 seconds. I am running a test with 20 clients. It is time-based benchmarking test on my test DB database. You can run time-based test or transaction-based test as well. So here is a time-based test by using -t with 20 clients are there. So let's, yeah, when you run Pgbench, it will start the vacuum. There might be some obsoleted rows are there that should be vacuum. So it will first vacuum and then it will do the transaction. Here are 20 clients are there. They are doing a transaction for 60 seconds on my test DB, which is having one branch where 100,000 rows are there. So we'll wait for 60 seconds. So it's doing transaction, and after that I'll get number of transaction, actual process rows, duration is a 60 second. Also I'll get TPS. It's showing vacuum because of obsoleted rows. It's going to, yeah. So here the scale factor is 2 because at the initial time I have given the scale factor 2. Number of clients are 20. Duration is 60 second. Latency average I got 14.58, and the TPS including connection established and TPS excluding connection established. So if you run this test again, there is some overhead will happen on the database because update will generate some rows, insert will generate some rows. So what I will do again, I'll do the same test on my database. So we can do Pgbench again and again, and you can find out that what is the TPS. So let's say again I'm doing. So in this way, I am checking my database for 20 clients doing a transaction for 60 seconds. How many rows as a scale factor is there? So it's showing scale factor 2, that is nothing but 200,000 records are there. And for 200,000 records, I'm doing these operations, and the simulation is like that 20 clients are there. And when I will do such operations on my database, so what will be the TPS? I can get that idea. In this way, you can run this test again and again. You can give the load for your system and you can find out that what is the TPS. In this way, you can compare your database with other databases. Even you can find out that if the parameter sets are properly, then how much, whether the parameters are set properly and how much load it can capable, how much load it can handle. And when I'm doing that much load, what could be the exact TPS, that idea I can take. Then what I will do, I'm doing another Pgbench test with 20 client. Here I am doing, instead of there, I am doing some transactions. How many transactions I am doing? That is 100 transactions I am doing on my test DB. With 20 clients. So yeah, definitely it would be the fast. Yeah, so in this case, see here, number of clients 20, number of transaction per client, that every client, that is 20 clients are there, every client has done 100 transactions on my database. And in that case, latency average is 16.62, and the TPS which I got 1202, including connection establishing, and 1204 excluding connection established. That is around similar. This is about the benchmarking which we have done. We have run Pgbench test. We have seen that number of clients. We can increase the number of clients. we can increase the time, you can increase the number of transactions, you can do the load on particular database, and you can find out what is the exact TPS you are getting for a particular load. Now we'll move to the DRITA. DRITA is dynamic runtime instrumentation tool architecture. It comes along with Enterprise DB Postgres Advanced Server. This is one of the tools available in Advanced Server, which can be used to find out wait events. As a DBA, most of the times DBA think that whether the AWR type of reports is available in PostgreSQL. So ADB Postgres Advanced Server, it has a capability of DRITA functionality that will help you, the DBAs, to find out the wait events they can do, and that will help you for the performance tuning, which can be used to find out wait events, as I said, that are affecting the performance. So this is one of the performance tool available in Advanced Server, and it is already installed with the Advanced Server. DRITA records wait events information while consuming minimal resource. That you can run a DRITA tool, you can take snapshot. What I can do, that means when I'll run the DRITA, by using DRITA, I can take the snapshot. Again, I can load some data into the database. Again, I can take the snapshot. I can take multiple snapshot. By using unique ID, I can compare the snapshot and I can find out the wait events. These snapshot contains the wait information, the information about system wait, about session wait, which is stored inside the DRITA catalog. And using those snapshots, we can evaluate performance of particular system. Let's say that you are running a workload and you want to find out that what different weights are affecting the performance of that workload. To find out that information, you can use DRITA snapshot. So you can run snapshot, then run the workload, and then again, you can take a snapshot, and then you can compare these two snapshots. Comparison can be done in order to evaluate overall performance of the system. The snapshots that are taken by DRITA are unique identified by ID, which is the ID number. Functions are available for, there are different functions are available which will use to create the snapshot. You can view the snapshot, you can compare the snapshot. While running the DRITA on PostgreSQL or ADB Postgres Advanced Server, it consume minimal system resources. That is nothing but a very low overhead. There is no impact of performance on the PostgreSQL. So when you want to configure DRITA on ADB Postgres Advanced Server, you have to do some changes. You have to change some parameters. So we have the parameter that is timed underscore statistics. Because we are getting some timing information, that's why you have to change these parameters in the PostgreSQL.conf file. Just open PostgreSQL.conf file and set your timed underscore statistics parameter false to true. By default, it is false, and you can make it true. So in order to collect timing information on your server, because this is information required by DRITA snapshot, that's why we have to set timed underscore statistics parameter to true. On the hand, if you are taking snapshot in that session, you can turn on the timed underscore statistics is equal to true. So that is one of the prerequisite requirement while running DRITA functionality on PostgreSQL. Now DRITA snapshot. We will see that how we can take the DRITA snapshot. A snapshot is a saved set of system performance data at a given point in time. A unique ID number which identifies each snapshot. Whenever you use DRITA, you take a snapshot of performance data of your server. So snapshot is a saved set of system performance of your data. So all the wait events, all other information that is performance related information is saved inside the server. And when you take a snapshot, and that information is for the server at a particular time, when you take that snapshot, now snapshot is identified by unique ID, And snapshot ID is used by the function later on whenever you want to compare snapshot or you want to generate a report of a system weight from that particular snapshot. So that means how to take the snapshot. This is the process, this is the way where you can follow to create a snapshot, which is a beginning snapshot and ending snapshot. Between two snapshot, when you're taking the snapshot of particular database, then you have to run the workload, let the workload finish. That means, let's say that here on a slide, I am taking a snapshot, and to take the snapshot, I have used the function that is edbsnap. So I'll say select star from edbsnap. This is the take a beginning snap. Then do the workload on your database. You can take multiple snapshot, and at the ending, you can take an ending snapshot by using the same function that is a select star from edbsnap. DRITA functions, and these are the DRITA functions. I have taken multiple snapshot. I can compare these snapshot. I can find out the wait events in my earlier snapshot and in my ending snapshot. Based on that, what is the wait events? What is the system impacted? I can find out. But when I'll take the snapshot, I have to find out how many snapshot I have taken. I want to see the list of current snapshot. For that, you can use get_snaps function that will help you to find out how many snapshot you have taken. This will return you snapshot with ID timestamps when they were taken. Once you have snapshot ID, now you can get information from those snapshot. So if you want to view snapshot weight information, you can use the functions like sysreport. Those select star from sysreport, 9, that is a snapshot ID, initial snapshot ID, 10, the ending snapshot ID, and the last 10, it is a top n rows. That is nothing but through number of rows, just I want to see top 10 rows, top 10 events I want to find out. That's why select star from sys_rpt function is used here. There are other functions are there. So like session RPT, again you have to provide beginning ID, ending ID, which will give you the session weight information, which can be used to view session weight information for a particular backend ID. So you can provide the snapshot ID, and PID of user will give you weight information for that particular session. Once you have information which is stored inside session, inside the data snapshot, next thing you want to remove the snapshot, you can have the purge functionalities as well. So here I can find out the session ID. I can get the session report here. Apart from that, session history, as I said, and if you want to purge the snapshot, you have taken multiple snapshot are there. You want to remove that snapshot. So purge snap function is used to purge a range of snapshot from the snapshot table. So select star from purge snap, just provide initial ID and the ending ID so that it will purge the snapshot between these two IDs. There are again some of the simulating Statspack functions, but before that, just let's go for the demo part, that how we can take the snapshot. Let me show you this one. As I said, you have to configure the data. Data functionality is already installed when you install Enterprise Postgres Advanced Server. Just what you have to do, you have to configure, you have to enable data functionality by PostgreSQL.conf file, or you can do by session level. So just let me connect to my database, that is I have testdb already here. So PSQL. I have connected to my testdb. I'll do set timed_statistics. There are two ways. For session level, I am setting this parameter, which is true. I have some questions that Pgbench is nothing but AWS Statspack report in Oracle for performance analysis. Yes, it is similar to that one. When execute pgbench-c, DB name is affect performance, right? Yes, it is right. So now set timed underscore statistics, which I am going to set true because I want to enable DRITA on my database. So this parameter, either you can open the PostgreSQL.conf file and you can do at a cluster level, or here I'm going to do it at a session level. So simulation Statspack functions are there. So before that, we were discussing about session history, RPT, session wait information for specified backend. So I'll get select star from session history RPT. I will provide the initial ID as well. So now let me show you. Let me open my instance. So here I have enterprise DB. What I'm doing, I have taken the snapshot for my database. So I'll connect to my database PSQL test DB. And when I connect it to test DB, again, I have to set my time underscore statistics equal to true. So I set the statistics is equal to true. Now I'll take this snapshot. So select star from EDB snap. So I have taken one snapshot here, then run the workload that you want to evaluate when the workload has to complete to take another snapshot. So what I will do, I'll create the table, but before creating the table, I'll take one more snapshot. I'll take one more snapshot. Again, I'll take one more snapshot. Again, I'll take one more snapshot. I'll create some table, that is I'm creating table T1 as integer. I'll insert some values, insert into T1 values, that is, again, I'll insert values there. Again, I have inserted values. So select star from T1, or I can say that insert into T1, select star from T1. So again, I am inserting some rows. I have inserted many rows. That is nothing but I am doing some transactions, doing some load. So now again, I'll take the snapshot. After you take the snapshot, what I have to do that I'll get the information of my snapshot, select star from get underscore snaps. So these are the snapshot which I have taken. I can take many more snapshot and I can compare these two snapshot by using the functionality. So first of all, what I will do that I want to see the system reports. So for that, what I will do, select star from sys underscore RPT. And I can provide, for example, between 3, 4, this is the snapshot, and top 5 rows I want to find out. So here it has given me some of the information, that is a beginning ID. So beginning session identifier, it is showing ending ID as well as the wait counter, that how many times that event particular has um, wait for particular time, as well as the name of the wait, the number of times the wait event occur, wait time, the time of wait events in the second, percentage wait, the percentage of the total wait time for the session. I will get another information, that is select star from session underscore RPT. I'll get a session report, and for that again I will provide my snapshot ID 3, 4, and I can say that top 5 rows. So I'm getting particular ID, process ID of the session, user, the name of user incurring the wait name, the name of the wait events, count the number of times the wait event occur. So I'm getting this information. Now let's move to the next part, that is I'm going to simulating Statspack functions, that I can simulate my DRITA report like a Statspack or AWR in Oracle. So the function described in this section returns information comparable to the information contained in the Oracle, that is Statspack or AWR report. When taking a snapshot, performance data from system catalog table is saved into history tables, and the reporting function listed below reports on the difference between two snapshots. So EDB report will provide the detailed report of stat database report, stat table report, statio table report, stat indexes report, and statio indexes it will provide. So for that purpose, I have a select star from EDB report, that functionality when I will run, it will show me the information about DB report, stat table report, statio table report, stat indexes report, statio indexes report, and all these reports can be executed one time. That is, these reporting function can be executed individually, or if you want to execute all 5 functions by calling the EDB report function, will help you to get the information about all the reports. So now let's move to the, I'm going to run my EDB report here. So for that, select star from EDB underscore I'm running these functions. For that, I'll provide snapshot IDs. And let's say that EDB, no need to give underscore. Yeah. So enterprise DB report for database, it is similar to AWR report, where I'll get the version of my enterprise DB Postgres advanced server. It will show you, just go down, top 10 relations by pages. So Pgbench accounts, top 10 indexes by pages, system weight information, database parameters from PostgreSQL.conf, that you will get PG stat database data. Just go downside, you will get this information, the number of transactions which I have done, statistics DB report you will get, and moving to the next point. See, the following data catalog view provides access to performance information related to system weight, EDB dollar system weight that is select star from sys.edb $system underscore wait. So total number of wait and total number of wait time you will get. By using edb session underscore waits, total number of waits and total wait time per session, you will find edb session underscore wait underscore history. This view contains the last 25 wait events of each backend ID active during the session. For that, what I will suggest, let's see, select star from that is sys.edb $system underscore waits sys.edb $system underscore wait. So might be some typo issue. So the total number of waits, total wait per session, you will find out with these functions. And apart from that, let me move to the next part, that is using data reports for benchmark for performance tuning. So review the top 5 events in the given report, which will help you for performance tuning. Review the top 5 events in the given report. Looks for any event that takes a disproportionately large percentage of resources. Also, weight should be evaluated in context of CPU usage and total time when evaluating events. Watch for checkpoint weights, wall-related weights, SQL parse weights, DB file random. So this will help you to an event may not be significant if it takes 2 minutes out of total measure involvement of 2 hours of the rest of the time to consume by CPU time. So in this way, you can find out DB file random reads, DB file random writes, and B-tree random lock acquires. Apart from that, there is a Postgres Enterprise Manager, which is an enterprise DB's monitoring tool, and that will help you to find out wait counts, percentage wait graphically, percentage of time waited by using where we can see the weights for wall writes, wall flush, wall file sync in this way. So in this way, I have tried to show you how we can run the snapshot, how you can take the snapshot, how we can compare it, and how you can run the DRITA utility, as well as how we can do the benchmarking on particular database. So this is what I have done. So I'm done from my side. Thank you.
Thank you, Mansur. We have a few questions for you before we conclude the session. The first question I have is, someone is asking, I want to migrate from Oracle 12G to PostgreSQL. How is this benchmark useful?
So while doing the migration, what you can do, that you can find out how many TPS for particular transactions, or you can write the customized script on Oracle. The same customized script you can run with the Pgbench on PostgreSQL, and you can find out what is the TPS differences. Based on that difference, you can calculate that how much my system is capable to handle the workload. So in this way, that can be useful to find out the TPS or to compare the two databases.
Okay. Can DRITA snaps affect performance?
As I said, DRITA snapshot never affect the performance. It consumes minimal resources.
Okay. How to schedule regular snapshots getting created? Also scheduling regular purge of the snapshots.
So you in advanced server, we have the DBMS job functionality is there. So you can schedule that jobs for taking or purging the snapshot.
Okay, the next question is using DRITA and Pgbench for PostgreSQL, is it free for wrappers?
See, this is available in Enterprise DB Postgres Advanced Server. Data functionality is there. So there is some limitations in PostgreSQL, but these are available in Enterprise DB Postgres Advanced Server. So that's why sometimes ADB Postgres Advanced Server is compatible with Oracle, and those customers who are planning to move away from Oracle, then this utility can be helpful for doing the benchmarking, and ADB Postgres Advanced Server has that Oracle compatibility features are there.
Okay. What is a scale factor in Pgbench?
The scale factor, that is nothing but I have shown some banking application example where there was a one bank and 1 lakh accounts were there. Now I want to put more load on my database. So in that case, I can increase the scale factor so that I can increase the load on my particular database. And by increasing the load, I can do the benchmarking to find out whether the particular database is enough capable to handle that particular load. So when you increase the scale factor, automatically it will increase the load on particular database.
The next question is how to export the DRITA performance report in CSV.
Data performance in CSV, yeah, you can use simple copy or move command. You can use that one. That will help you to take the data report into the CSV.
The next question is, can we get the list of top SQLs in the database based on CPU time or elapsed times like we have in Oracle AWR?
Yeah, that you can do. You have to write the script. By using the script, you can take that particular top events from the report.
What is scale factor in Pgbench?
We have discussed.
I think we discussed this already. Next question is, what are WAL related weights?
WAL, yeah, WAL, that is a wall level events are there.
Wall level.
So yeah, wall level, whenever we are doing the transaction, and there is an switching from one wall to another wall, or there is a moving from one wall segment to another wall segment. So such type of events you can capture.
Okay. Someone is asking, please, can you share this PPT slides? Yes, Suresh, we will share the slides and the recording with you in some time. Next question is, how is it implemented in a distributed environment?
Distributed environment, see that even I have not worked on that, so can't say right now.
The next question is it available from database version 9.6? And how is DRITA different from the previous version? What are the new enhancements?
See, there are not major enhancement in the DRITA functionality with some addition columns or for some catalogs, but yes, it is available in 9.6.
Okay. Is AWR can be implemented on EDB and PostgreSQL open source?
AWR, it is a Oracle's proprietary data utility, so you can't implement in PostgreSQL as well as in EDB, but you can simulate with the help of data functionality in EDB Postgres Advanced Server.
Okay, I think that's all the questions we have for the day. Thank you, Mansur. Thank you, everyone, for joining us. We will soon share the webinar recording and slides with all of you. Thank you very much for joining us today. I hope you have a good rest of your day. Thank you.
Thank you.